show that 53 power 53 minus 33 power 33 is divisible by 10. For proving this, we are going to use binomial expansion. X plus y whole to the power of n is nc0 x power n into y power 0 plus nc1 x power n minus 1 into y power 1 plus nc2 x power n minus 2 into y square plus so on. Last term is ncn x to the power of 0 into y to the power of n. Now the expression is 53 whole to the power of 53 minus 33 whole to the power of 33 can be written as 50 plus 3 whole to the power of 53 minus of 30 plus 3 whole to the power of 33. Apply binomial expansion to both of the binomials. Then first binomial 50 plus 3 whole to the power of 53. Expansion is nc0. n is the 53. c0 into x to the power of n. X is the first term. 50 whole to the power of n is the 53 into y to the power of 0. Y is second term. 3 to the power of 0 plus nc1. n is here 53. c1 into first term is the 50 whole to the power of 52 into second term is the 3 to the power of 1 plus 53c2 into 50 whole to the power of 51 into 3 square plus so on. Last term is 53 c53 into 50 whole to the power of 0 into 3 to the power of 53. This is expansion of the first binomial. Minus of second binomial is nc0 is 33c0 into 30 whole to the power of 33 into 3 to the power of 0 plus second term is 33c1 into 30 whole to the power of 32 into 3 whole to the power of 1 plus 33c2 into 30 whole to the power of 31 into 3 to the power of 2 plus so on. Last term is 33c33 into 30 whole to the power of 0 into 3 to the power of 33. Then let us simplify these two binomial expansions separately. We get first binomial expansion is 53c0 into 50 whole to the power of 53 plus 53c1 into 50 whole to the power of 52 into 3 to the power of 1 plus 53c2 into 50 whole to the power of 51 into 3 square plus so on. Last term is 53c53 into 50 whole power 0 into 3 to the power of 53. Observe all the terms of this binomial expansion. First term is 50 whole to the power of 53. Nothing but this is a multiple of 10. And second term is also multiple of 10. Third term is multiple of 10. Like that all these terms are multiples of 10 except that the last term. Why? Because of last term is 53c53. It is like ncn. ncn value is 1. 50 whole power 0. It is like a power 0. A power 0 value is 1. And this is 3 to the power of 53. So if we take 10 common from all these terms except that the last term, we can write it as a 10k1. All these terms we can write them as they are multiples of 10. 10k1 plus last term is 3 to the power of 53. And after that second binomial expansion 33c0 into 30 whole to the power of 33 into 3 to the power of 0 plus 33c1 into 30 whole to the power of 32 into 3 power 1 plus so on. Last term is 33c33 into 30 whole power 0 into 3 to the power of 33. If we observe this second binomial expansion, first term is multiple of 10, second term is multiple of 10, third term is multiple of 10. all these terms are multiples of 10 except that the last term. So that it can be written as 10 into k2 minus of 10 into k2. Last term is not multiple of 10. We can write it as 33c33. Again it is ncn, which is equal to 1. And 30 whole power 0, it is a power 0, which is equal to 1. And 3 to the power of 33. 10k2 plus this last term is 3 to the power of 33. If we open the bracket, it becomes 10k1 plus 3 to the power of 53 minus 10k2 minus 3 to the power of 33. Now let us take 10 common from 10k1 minus 10k2. It becomes 10 into k1 minus k2 plus 3 to the power of 53 minus 3 to the power of 33. Now k1 minus k2, it is some integer. So 10 into some integer, again it is divisible by 10. We can write it as 10 into some k, which is a multiple of 10. Plus, from these two, we can take out 3 to the power of 33 common. Then this becomes 3 to the power of 20 minus 1. See, it is 3 to the power of 33 into 3 to the power of 20. It is like a power m into a power n, which is equal to a to the power of m plus n. If we apply that formula, this becomes 3 to the power of 33 plus 20, which is equal to 3 to the power of 53 minus last term is 1. Now it is 10k plus 3 to the power of 33 into 3 power 20 can be written as 3 power 4 whole to the power of 5 minus 1. It is a power m whole power n, a power m whole power n, which is equal to a to the power of m into n. So it becomes 3 to the power of 4 into 5, which is equal to 20. Now it is 10k plus 3 to the power of 33 into 3 power 4 value is 81 whole to the power of 5 minus 1. Then this becomes 10k plus 3 to the power of 33 into 81 whole to the power of 5. Whatever these digits may be, units digit is 1. 1 power any number, we will get the units digit is 1 minus, again we have one more 1 there. It becomes 10k plus 3 to the power of 33 into last digit is 1 minus 1. We will get many digits here and units digit is 0. So that this number 10k plus 3 to the power of 33 into whatever these digits may be, units digit is 0. We know that if units digit is 0, that number is divisible by 10. So finally 10k is divisible by 10 plus 3 to the power of 33. This is also multiple of 10. So that this first term is divisible by 10 and second term is also divisible by 10. Finally, we can conclude that 53 whole to the power of 53 minus 33 whole to the power of 33 is divisible by 10. Thank you.